So now let's take our Gaussian and convolve it with the image. So now remember that A is 512 by 512 by 3, which is a three-dimensional matrix, and H is a two-dimensional matrix. So if I try to do this, I'm going to get an error. Oh, sorry, we are using the conv2 function, and you still get an error because A is not supposed to be a three-dimensional matrix, right? So if we look at the definition of convolution, we're working with two-dimensional matrices if we have two-dimensional convolution. So what we want to do is let's just take the red channel, right? It doesn't matter which one, because remember when we were looking at the red, green, and blue channels, we pretty much saw the same image for every channel. Okay, so we still get another warning, and that's that A is still in values of uint 8. So let's change that to double. Okay, so now let's IM show C, see what we get. So it's all white, and so what does white mean? That means all the values are too high, right? So there's too much intensity in this image. So you have to play around with the values a little bit. So let's try making a smaller filter. Okay, so let's say H is equal to my Gaussian 25 and the sigma is 5. I am show C. So now the filter is smaller and the sigma is smaller, so the blur is going to be less, but the intensity is still too high. So that could mean just the values are too high and we need to multiply by lower values. So let's divide the filter values H by 1000. I am show C again. So now we're starting to see some black, right? So that's good. Okay, so I'm decreasing the values and I'm starting to see the image. Okay, so here's the original image but blurred using a Gaussian of sigma equals 5. Now, one thing I didn't show you guys because I wanted you to go through the exercise of creating a two-dimensional Gaussian filter yourself is that we already have a function called fSpecial in MATLAB that creates filters for us. And so fSpecial can create many different types of filters. So in addition to the Gaussian, it can create Laplacian filters, an averaging filter, which is another thing we've used, a Sabel filter, which is useful for finding edges. So all different types of filters. So let's try using fSpecial instead. What was fSpecial? Now let's do our convolution. So I'm going to divide by 1000 because I know I'm going to have to divide. Show C, let's just see what we see. Okay, and so it's a little dark, so I didn't have to divide by 1000. Maybe I could have divided by a lower number. But you can see the idea is that we've blurred the original image using the Gaussian filter given to us by fSpecial instead of our own Gaussian filter that we built. Okay, so like we did before, I want to plot the filter that we created. So I'm going to go IM show little h, which is the filter we created with f special. And notice how it's just all black. Remember that 0 is black and 1 is white. So what we could do, we want to look at what's in h. Let's check the maximum value of h. So max because it's two-dimensional. So the maximum value is 0.0065. So of course, when we plot that, it's going to be pretty close to black. So what we could do, if we wanted to scale it by 1, we want the maximum value to be 1, is we could do IM show h divided by the maximum value. Okay, so now we see what we expect to see, which is white in the middle. So one question you might have is, why is the value of h so small when we use f special? And that's because it does a thing called normalization. So if you have ever studied probability, you know that a probability distribution has to sum to 1. So here it's a similar thing. So if we sum across both dimensions of h, we get 1. And so that's why the values of h are so small. And so now, just for completion's sake, I want to do sort of what's the opposite of blurring. I want to do edge detection of the image. So I want to find all the edges and set those values to 1. So MATLAB has a method called edge that will do this, and it's very simple to use. You pass in again the grayscale image, right? So only a two-dimensional matrix, it won't work if you pass in the entire image matrix. Okay, so edge just does all of that automatically for you. So if I IM show E, I can more or less see where all the sharpest edges are. And of course there are parameters you can pass into edge to make it more or less sensitive, but this is by default what it does.